Hello students. So let us start with the first problem of centroid. So the problem will be given either to calculate the centroid of the given figure or to determine the centroidal axis of the given figure. So in this problem it is given that determine the centroid of the lamina as shown in the figure. So this is the given figure. So in this figure this is a T section. It is given that the topmost, this is called as a flange and this is called as web. The flange is given as 100 mm by 25 mm and the web is given as a 70 mm by 20 mm. It is given. So all the dimensions are in mm. So whenever you start with the first problem, draw the figure in your notebook carefully without missing any data. So then first thing is you have to check whether is it symmetrical about any axis. You have to check it. So now definitely it is symmetrical about the y-axis. So this figure is symmetrical about y-axis because this axis divides the left and right portion into two equal halves. So therefore if you have this type of problem, so here therefore you will have x bar is equal to 0. So therefore no need to find out x bar. So already we got the symmetrical y axis. Now only have to find out symmetrical that is centroidal x axis you have to find out. So now to draw this, first you have to draw this figure into this and you have to draw divide the areas based upon either rectangle, triangle, whatever it is given convenient, the areas you have to write. So here I have divided the first flange as 100 mm by 25 mm as first rectangle, and this second rectangle I have taken as 70 mm by 20 mm. So you are, for your convenience, so how many simplifications you can make it, so so many numbers of one shot. And therefore after making into areas, you have, since you have to find out y bar, so you have to consider a reference axis. So the bottommost point you have to take it as a reference x axis. So here x axis is the reference axis to find out y bar. So we have to draw this rectangle, that is the centroid table. So here since you have two figures, serial number will have 1 and 2. The components both are rectangle, so you have to write rectangle and you have to take it areas. So and this is the area, since these are in mm, so you have to write area is in mm square, and the centroidal distance from x axis. So since you have only, you have to find out y bar, so this is only you required. So centroidal distance from x axis, so that will you will get it in y, in mm you will get. So then you have to do a into y, so therefore a into y is required. So then first area 1 is 100 mm into 20 mm, so you will get it 100 mm into 25, you will get area as 2500 mm square. Then area 2 will be this area, so that is 20 mm into 70 mm, so you will get 1400 mm square. So then total area will be, add all these two areas, so 2500 plus 1400, you will get 3900 mm square. Next, the centroidal distance from x axis, so that is you have to calculate the centroid of these figures from x. So first for this area, this is the centroid. So therefore the centroid distance will be from here to here. So this distance will be from here to here 70 you have, and in this is d by 2. D by 2 is 25 by 2. So 70 plus 25 by 2, you will get 82.5 mm. So this is your y1 distance. Next, similarly you have to find out for this second area. So this distance will be, so centroid of second distance is from here. Once again this is y2. Y2 will be the, from here to here, the second area distance is 70. 70 by 2 is 35 mm. Okay, so then after finding area and y1, so calculate ay1. This is ay2, this is ay1 and this is ay2. Then add this, summation of ay is this value. So therefore y bar is equal to summation of ay divided by summation of a. So I'll get it. So this is, therefore y bar you got it as 65.45 mm. Thank you.